Welcome to qnawire.
To figure how much energy is required to lift the electron from the n equals 1, so n sub I, the initial, is equal to 1, to the final state, n sub f, being equal to 2, we use the fact that the energy is equal to the ground state energy, 13.6 eV, times the 1 over the initial state squared minus 1 over the final state in the transition squared. So this would be 1 over 1 squared minus 1 over 2 squared. Carrying operation, we find that it comes out to equal 10.2 electrons, which is our answer to part A. But we notice in part B, we're trying to solve for the temperature T using the Boltzmann constant, which has SI units. So we want to convert from electron volts to, so there's 1.6 times 10 to the minus 19 joule in every 1 electron volt. So this comes out to equal 1.6 times 10 to the 18 joules. Both are correct, so we can go ahead and box both of them in as the solution for part A, but we're going to use the joules version as our value for part B when it comes to solving for the temperature. So now all we have to do is solve for T, and we find that T is going to be equal to the square root times the energy, which we found part A, divided by the Boltzmann constant, Kz. Again, we're using the joule version of energy. This gives us a value in units of spins. So this comes out to equal 0.88 times 10 to the 4